Atomic absorption spectroscopy. Here, the absorption of atoms will be seen in this topic. The measurement of absorption of atoms in a sample can be explained by in this atomic absorption spectroscopy. The atomic absorption spectroscopy, it deals the absorption of specific wavelength of radiation by the neutral atoms in ground state. Here in this spectroscopy, the ground state and excited state will be occurred. The phenomenon is which similar to the ultraviolet spectroscopy, where the absorption of radiation by molecules will be occur. Neutral atoms are obtained by the spraying of sample solution of elements using a burner like flame photometer, and the specific wavelength of radiation is generated by using a halo cathode lamp HCl, shortly we can call it. For determination of every element, separate halo cathode lamp is required. The principle of atomic absorption spectroscopy is when a solution of metallic salt is sprayed onto a flame, fine droplets are formed. Due to the thermal energy of this flame, the solvent in droplets will be evaporated and fine residue will be formed that converted into the neutral atoms. The neutral atoms which absorb the radiation of specific wavelength and which that emit the halo cathode lamp by the neutral atoms absorb the radiation of specific wavelength and then it emit by HCl. The halo cathode lamp is filled with vapor of elements and which gives the specific wavelength of radiation. For the determination of every element, HCl is selected and atomic absorption spectroscopy is achieved by only using the HCl halo cathode lamp. The intensity of light absorbed by the neutral atoms, which is directly proportional to the concentration of elements, and it obeys the Beer's law. And the intensity of radiation absorbed by neutral atoms is measured by using a photometric detectors like example phototube detector or photomultiplier detector, tube detector. When a metallic salt solution liquid sample is sprayed on a flame which forms droplets and it evaporates and form a fine residue, then it will be converted into the neutral atoms. The neutral atoms will absorb the specific wavelength of radiation from halo cathode lamp. Here the measurement of intensity of radiation can be absorbed by using the photometric detector, which is shown in a short. And in atomic absorption spectroscopy, the temperature of flame is not critical and the neutral atoms, since the thermal energy of flame is used just to atomize the sample solution to the fine droplets. The number of elements which can be determined by the atomic absorption spectroscopy, which is far, and when compared to these, it can be analyzed by flame photometry. Here the halo cathode lamp, which is used as a absorption wavelength absorber, the lamp or the source of light in atomic absorption spectroscopy is used as a halo cathode lamp. Halo cathode lamp is used as a source of light in atomic absorption spectroscopy. This cathode is made up of specific elements like alloy of elements are coating with the cathode. When current is applied between anode and cathode, the metal atoms emerge hollow cup and collides with the filler gas, which normally argon or neon. This characteristic radiation is absorbed by the neutral atoms of the same element in ground state and which occur the flame when sample solution is sprayed. It is not possible to use the source of light with a monochromator because this arrangement gives a radiation with a bandwidth of 1 nanometer. So, whereas the halo cathode lamp gives a width of 0.001 to 0.01 nanometers, which is highly desirable to achieve specificity. Moreover, the light source should provide a line width less than the absorption line. When we compare to the ultraviolet spectroscopy, here the line source should be provide the line less width when compared to other spectrometers. The determination of every element can be separated by the HCl. So it is a demerit of atomic absorption spectroscopy. Here the burner, halocathode lamp, chopper, monochromator and amplifier, detector, residue readout device will be used. Here we can see the diagram. In this diagram, the halocathode lamp is there, which is made up of glass or pyrex, and the gas is filled with the argon or any other neon gas, and anode and cathode is there. The silicon window is there. The chopper which is used to spread the gas onto the flame. The flame is placed in between the monochromator and chopper. The burner which is used to blow the flame, and the sample solution is placed beneath the burner, and the mixer is there, and then grafting monochromator